Question number 29 of the PhilNITS FE morning portion of the exam. In this question, we are being asked, which of the following is a public key cryptography algorithm whose security depends on the difficulty of factoring extremely large numbers into primes? Okay, this question, I think, somehow the correct answer, which is letter D, proved to be what I chose because the other ones didn't seem to be something that I knew, except for AES. AES, I think, if you've used a Windows operating system where you needed to connect to the internet, it's likely that you've seen AES in one of those Windows properties. Where, for example, if you need to connect to your router and you find an access point, then it's likely that you'll be asked for a network security key. And there is a portion there where you have encryption type, where you got the AES, Advanced Encryption Standard. And therefore, you need to input the password, the key, to access the internet through the router. And in this case, what we're going for is a public key cryptography algorithm whose security depends on the difficulty of factoring extremely large numbers into primes. And if you have a password that you enter to access the internet, for example, then it looks like it's not this part where you have extremely large numbers into primes. So AES, I thought, was unlikely gonna be the answer. DH and DSA, I wasn't really too sure whether these are things that I've encountered before. Although what I did know is RSA. If you look at RSA, we have here Rivest, Shamir, Adelman, and the fact is I've used RSA before to put a security measure on one of our servers, and a web service that has an RSA encryption should be able to, at least to a certain extent, protect users from any of those attackers that want to steal their passwords or something. Because if you have a login page and then you enter your password there without the RSA, so instead of HTTPS you get HTTP only without the S at the end, then it seems that it's a lot easier for attackers to get hold of your password because they won't need to do an additional decryption. However, we also know that the pitfall with SSL RSA technology is that how would you get the, for example, the private key? If we look at the question here, it's a public key cryptography algorithm, um, but also it has a private key. And if you are gonna receive the private key over the internet, and there are people already who can sniff out the email, for example, then they already have access to the private key. And usually the people who continuously attack websites, web services, are those who really do that. They look for emails or any of these messages that have the RSA or any of the keys and then from there they can find out if you are using RSA this key for your web service. Then they already know that you'll need a private key as well, and they'll just look it up and find that your private key is this set of numbers. And so eventually I thought that if I'm going to receive the private key over the internet, then it's not going to be much use to me anymore, right? Maybe if I were to get the private key from another person, not via the internet, but actually maybe over some kind of USB or device, then maybe it's going to be a lot more secure. However, how am I going to get that? Maybe I'll need to travel to another country and then bring it here. So we have the distance aspect, which translates to time to get hold of the key, which translates to more money being spent. Which eventually we also know that the idea that that's why we have the internet, to make things a lot faster, a lot more efficient. And if we always have to regularly um, travel from this place to another country just to get hold of the updated key, then it seems like we're going to the opposite direction. And if so, why are we even promoting the internet if we know that it's not as secure as it should be? So the end result is I opted not to continue on with the RSA. Let me just share my references. I have here rapid SSL and then .ph for the for example usbong.ph, the website that we have. And if you want to look up more details about this sort of thing, then you can check out google.com. Of course, there's also something written here, 10,000 US dollars warranty. But of course, we also know that I think the problem would be, how can you prove that someone actually broke into your web service? And do you have any of these digital footprints? And I think that if you are going for 10,000 US dollars to do that, and maybe later on create this case against these attackers, and it's maybe worth your time and effort, then you can attempt to do that. What we can find is that it seems like even large organizations, um, although they might know about the problem, they just go and, okay, let's open the internet more, get more people online. And so as more and more people go online, then if more and more people are aware of this problem, then somehow we'll figure out how to solve it, right? If there are more people who can see that, hey, someone's actually messing around with my account, someone's actually looking into how much money I have without authorization. So if more and more people encounter that problem, then we may predict that someone's gonna do something. Someone with the power to change things. Because if only one person who seems to have something, and the big organization doesn't see that the complaint is huge enough, then we can see more and more people just continuously using the service, and not having this case against these attackers. Now, if we are going to go and look at the other choices, DSA and DH. DH means Diffie-Hellman. It's an encryption algorithm as well, and it uses a public key. And it looks like this could be an answer too. And if we look at how it's supposed to work based on the diagram, we are gonna generate a value, and then the other person, if we are two persons, the other person will also generate a number, and then we are supposed to do some kind of computation that would lead us to a key that can only be computed if we have the numbers that we generated. So the two numbers x and y, if we don't have those, we won't be able to get the final computation, which would be the key. And having a set of generated numbers and then another set of numbers after doing a computation um, creates this security, a level of security when we send information online. And of course, you may read this part some more and see if there's anything that maybe would explain things a lot more clearly to you. I got this from Science Direct. Now, regarding DSA, I got this from Science Direct. Now, regarding DSA, which is choice number C, says here that it's supposed to mean digital signature algorithm. So, I think that the signature is supposed to tell us who owns what. Who is the person who, for example, created this file. But it doesn't necessarily do what we are going for, where you have an extremely large number and factoring that large number into primes. All right? Okay.